Today we're talking about ideal gas law, so we need to start with what exactly is an ideal gas. And the reality is there's no such thing as a proper ideal gas. These are conditions that we can approach but never quite meet, and our ideal gas law will describe a gas behaving in those ways. So it's never going to be exactly right, but we'll work with it as close enough most of the time. So in an ideal gas, you would have identical molecules that have mass but no volume, which right away isn't possible, but we'll ignore that. And they follow Newton's laws of motion all the time, and they have no interaction, which means no matter how cold I get that gas, it would never liquefy, which is definitely not the case. But under, let's say, normal conditions, most gases do exhibit near ideal behavior, so we can use this. And anytime a real gas wouldn't, we'll ignore it. So it's going to work. It's going to be perfect. Okay, what's the law? Here's the law. PV equals nRT. I know we'll get there. So P is obviously pressure, V is volume. However, it's got to be in liters, and pressure is in kilopascals, although we haven't used any other unit. N is number of moles, as we've had for a long time now. R is new, it's gas law constant, and it's 3.14 liter kilopascals over Kelvin moles. And if you think that's a really crazy unit, the whole point of that nutty unit is to make sure everything else cancels out properly. And then T is temperature, and of course in Kelvin, because anytime we're dealing with gases, temperature has to be in Kelvin. Now I want to emphasize something, and that is I can take that formula, I can rearrange it. You don't need to write these things down, but if I'm solving for volume, the formula rearranges, or pressure, or number of moles, or temperature. And yes, I could solve for R, but it's a constant, so why would I? By the way, if I had volume in milliliters, or if I had pressure in some other pressure unit, my value of R would change. We don't need to worry about that because our volume is always going to be liters, our pressure is always going to be in kilopascals. Okay, we're going to go right into questions because that's all the background we need. So if you had a question where trying to find the pressure, I'm going to start the same way I always do, answer the question. Now in this case, I know volume, number of moles, R and T. I always know R, and I know what the rest of them are as well. So I'm just solving for pressure. At which point I rearrange the formula for pressure, throw things in, make sure all the units cancel out, and I end up with a pressure. Seems like a very large pressure. We'll talk about that some other time. But too easy. Okay, I can do something different with this. So if I had a mass of gas, well, this is new. We've never had that before. But it should make sense that gases are matter. They take up volume and they have mass. So if I were able to find the mass of a gas, now what? You'll notice I don't have changing conditions, which is kind of a new thing for us with gases. What we've been doing so far is, here's a gas, change it. I'm not making any changes here. Now, I don't have numbers of moles. I've got SATP, which is standard ambient temperature and pressure. So I have a mass, doesn't help. I have R, I have pressure, and I have a temperature. I don't have a volume, that's what I'm being asked for. I also don't have a number of moles, but I can find number of moles because I have a mass and I have a chemical formula, mass over molar mass. Everything else I know, I put that into the formula solving for volume, and I end up with a volume of that in liters. Too easy. Okay, what else can I do? If I know information about the gas, and I've got a mass and I've got a volume and I've got a temperature and I've got a pressure, I could use that to figure out the molar mass. Now, if you think way back to when we were dealing with simplest formula and molecular formula, we needed to know molar mass. And at that time, you were always given a molar mass. Hey, I don't need to give you molar mass anymore. I could give you gas information instead. Okay, now molar mass is mass divided by number of moles. I know the mass, I know the pressure, I know the volume, I know all that stuff. What I don't have is number of moles. Okay, so I can find number of moles because of what I have is a gas. Find the number of moles, put that into my molar mass formula, now I have my molar mass. So I could now have the molar mass of a compound that I'm trying to find the formula for. Now if that seemed like it was real quick, it was, because we've done a lot of this stuff before. We know how to do all of this stuff. It's just, hey, here's a couple of types of questions that you might see. So there they are. Talk to you later.